Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Wafi Taqiuddin Eusud, and today I would like to present my final year project titled of Development of Web Application Package to Size a Grid-Connected Photovoltaic System. Okay, let's go straight to the project, and this is my research award, which is I have won a Gold Award in National Invention and Innovation Competition, and the second one is that Gold Award in Research and Innovation Poster Competition RIPC, and submitted in two competition, which is International Invention and Innovation Competition, and also Sustainable Competition, which is 3MS, which is stand for 3 minutes speech competition. And this is the list of publication journal that has published in International Journal of Scientific Research and Engineering Development. Okay, let's go straight to the introduction. Okay. Electricity, its demand has been increasing year by year, and its generation is highly dependent on fossil fuel, which is always produce CO2 emission to the atmosphere, which is not very good to the environment. So as a big result, this statement that we should really need to use a photovoltaic system because it has the potential to design a future electrical system that is clean, reliable, and scalable. And due to its high efficiency, PV creates electricity from sunlight and transforms it to electrical energy. And it is also very dependent on peak sun hours, temperature, weather, and others. And PV capacity, inverter, and load need to be sized precisely. In conjunction with it, it does need a lot of effort in computational sizing method that has a lot of complex calculation. So the solution is I will develop a web application package based on Google site with integration of Photovoltaic, so that can help the user sizing the PV system easily. They just need to enter the information required. So the objective is first is to size a grid-connected photovoltaic system for a single-story terrace house. Second is to develop a web application package that can be sized that can be used to size a grid-connected photovoltaic system. And the third one is to ensure web application package by comparing the result with the computational sizing method. The last one is that to investigate the economic analysis for grid-connected photovoltaic system. And for the scope is, the project is focused on single-story house with maximum demand of 3 kilowatt in Malaysia. And the second one is Google Sites with integration of Photovoltaic is used as a platform to develop web application package. And photovoltaic panel that being used is a polycrystalline type. And the last one is that the climate condition based on Malaysia condition. So the next one is the literature review. Okay, what is this topic about? So firstly, the web application package, the combination of Google Site with integration of Photovoltaic. So basically, in this project, the embed code from Photovoltaic will be implemented in Google Sites, which is Google Site has a GUI that has a panel which has 3 tabs consist of insert, pages, and themes, where may easily and for free establish a website. Then the integration of Photovoltaic itself. It is an interactive Photovoltaic builder that allows users to create custom and made interactive Photovoltaic calculators and integrate them into their website. So obviously in this project I will embed code from the Photovoltaic into the Google Sites. So next one is the chapter 3 methodology. Okay, for the methodology is first I will do the literature review and discover more information regarding the sizing of PV system itself. Then do a data collection for single-story terrace house and grid-connected PV system sizing using computational sizing method. And if I don't get the data that I required, I will go back to data collection. And if I satisfied enough with the data, I will straight away develop the web application package. So then I will test the web application package, algorithm, and interface. If the interface and the algorithm is not obtained as the requirement, I will go back to development and design it from the start. And if it's all okay, I will go straight to the sizing using the web application package. Then do result analysis and discussion and do the computation of report. And this is the data collection that I have choose a single-story house at Jalan University And it is my rental house. The area of the house is 6 times 21 meter, and the rooftop is 4 PV panels of 5 times 2 meter. The second one is that the sunlight. The sunlight is the standard temperature condition, which is how we know the value is 25 Celsius. And for the coefficient sizing method, we have to calculate the PV panel, inverter, costing, and total payback period. So this is the Google sites that I have been created using it, and this is the integration of Calconic for the calculation that I have calculated for the estimated local consumption until TPP, total payback period. Okay, let's go to the chapter 4, results and discussion. For the result and discussion, firstly, the load analysis and energy consumption. This is the energy consumption that I have made, that have been researched from light to the kettle, and the total energy consumption daily it is 70,000. For monthly, it is 513 kilowatt hour, and the comparison between manual and website method, it is the same. It is the same as we got from the manual method. Later on, I will show the website. So next is the photovoltaic sizing. Photovoltaic sizing, which is for the PV out array, I will choose 350. For the PV panel rated is 355 watt, and power guarantee is 0.97, and number of array is 4. So we got 1377, and for the temperature corrected power output, it is 30 Celsius and 0.0036 with 35 Celsius STC, produce 1352 watt. The net power output is mismatches 0.03, and the power inverter maximum AC power output is 1500 watt with 0.93 efficiency. So for the daily, we got 4867 watt hour per day, and the monthly we have 146 kilowatt hour. So for the comparison between manual and website, it is approximately the same for the days, but for the month it is the same. For the tariff bill, we get total import 513 we obtain from monthly energy production and monthly energy consumption, the previous one, and 146 we got from monthly energy production. So the actual bill we got is like this, and spotted bill and total saving we have saved 11.57. And the comparison between manual and website also the same for import and export. For the costing also is this the value is the same. And also for the total payback period, the comparison between manual and website also the same. So which means the system that I have developed for sizing a grid connected photovoltaic system is accurate enough. Okay, so as you can see, this is the web application package that I have developed using Google Sites with integration of Calconic, and this is the home page. And at the right side, we can see that this is the GUI of the website, which is have insert pages and things that we can customize them. So this is the website. It consists of the home page, which has the load consumption, photovoltaic sizing, tariff calculation, costing, and TPP, the brief explanation of all of them. And in order to go to the next page, we can click the above. You can click here, or we can click the button that provided here, or we can click the next button that provided at the end of the page. So we'll go to the next pages, which is the load consumption. Here I have provided a manual guide for user so that the user can easily key in the data. And this is the estimated load consumption with the data that we require from the user itself. So we have to go to the next page, which is PV sizing, by clicking the next button. And in this page it is provided a PV module and inverter explanation, and also provided manual guide for user for friendly purposes. So for this section, also the user has to key in the data, which is I will show in this section, which is I have chosen 355 watt with a power guarantee 0.97, and number in PV array is 4. Then we'll auto calculate 1377. And the average temperature is 30 Celsius with the temperature calculation with 0.0036, and the standard STC is 25 Celsius. And the losses we get is around 0.03, and the maximum DC is 1.5 kilowatt, and the converter is 0.93, and the efficiency is 1. So it is auto calculate, and with the average PSH in Malaysia is 4, so it will auto calculate 4811 watt per day, which is slightly different from the manual method, but for the monthly it is the same as manual method. So we go to the next step, which is tariff calculation. Also provided manual guide for user, and also need to key in the data here from the user that we got 513 from the energy production, and we have to key in the data from here because it is need to be higher from 0.516. so it is the same as the manual method that I've explained before. And for the costing, we also provided manual guide. So for the cost per panel, this session is 500, and total 4 we need 4, and maximum is 4000, and total and the level is 2000, and the wiring you get is 30%. So we will auto calculate this total costing price, same as manual calculation. The total is 6,963, and for the last page is the total payback period, also provided manual guide. And so for the actual month we get here, just key in the data here that we got from previous calculation, 57, and the total monthly saving that we got from the tariff bill, 75.34, and the cost estimation from the costing that we got with one is 6963. So it will auto calculate the total payback period of 7.7 years, slightly same as manual method, but it can be considered as accurate. Okay, that's all for the website. So for the conclusion and recommendation, for the recommendation is that first, to enhance the web application package that may be used to determine the size of PV system for industrial application, and prepare the database for selecting PV panels using web application package. And the last one is that upgrade the web application package view capability into tablet and smartphone view. Also upgrade the user interface for a friendly user, for more friendly user. Okay, that's all from me. Thank you.